Hello, everyone, and welcome. Thank you for joining us for the latest DZone webinar. My name is Jason Cockrum. I'm the Community Engagement Manager here at DZone, and we're glad you're here. We've got an exciting and a really relevant topic for you today, so we're glad that you've joined us. If you're new to DZone, we are one of the world's largest online communities of software developers and experts. We publish all sorts of content for developers and anyone passionate about software development. We've got things like ref cards and trend reports, and thousands of articles written and published by our community, making us the go-to knowledge hub for software developers all over the world. We also do a ton of great events like this one today, and you can find all of them on our website at dzone.com/events. We've got fireside chats, we've got virtual roundtables, and who knows, maybe you'll see us at an in-person event sometime in the future. So be sure to check out dzone.com/events for all the information you need to know about our upcoming events. Today, we're going to be talking about how to create a better workflow for assessing the health of your data systems. As we all know, lineage is a critically important aspect of any root cause, impact analysis, or really any health assessment workflow. Today, Helena Munoz and Xuanzi Han from Monte Carlo are going to show us how to tackle this challenge by leveraging some of the most popular tools available today. Helena is a senior front-end engineer for Monte Carlo and has been building software for over 17 years. Xuanzi is a back-end engineer for Monte Carlo and has worked for companies like Uber and has experience with large-scale streaming processes using Kafka, Flink, and others. Here at DZone, we're all about community, so we encourage you to check out all of the stuff we have on our website. Consider maybe contributing as well, becoming a member of the website and joining us and contributing your own insights to our community. But at this point, I'm going to stop talking and I'm going to turn it over to Helena. Helena, take it away.
Thank you, Jason. First of all, thank you for having us today here and for the great interest. I'm going to now share my screen. Great, let's get started. Okay, so as Jason mentioned, I'm Helena Munoz, and together with Xuanzi Han, we will build a feature on Monte Carlo that's called FieldLevel Lineage. And the presentation today is going to be about how we build it. So also, as Jason mentioned, I was focused more on front-end and Xuanzi on back-end. And we structured the presentation today to first talk briefly about Monte Carlo, about the data observability category, about what we do for our customers. Then we're going to talk in particular about why FieldLevel Lineage is important and relevant within the context of data observability category, but also for customers. We're going to briefly discuss some use cases that are for which this feature is particularly helpful. And then we're going to talk about how we actually build this. Finally, we will end the presentation with a demo on how this feature looks in our product. So let's get started. So, okay, well, Jason already introduced us, so I'm going to skip this. And then I'm going to talk about Monte Carlo. So both Xuanzi and me have been from Monte Carlo for a bit over 2 years now, but the company has been around for 3.5 years or so. And Monte Carlo is the creator of the data observability category. We have more than 230 million in funding, which was done by one of the world's best enterprise companies, such as Axel, GGV, Redpoint, Iconic, and IVP. And we are very proud of our very big customer base, which is growing quarter by quarter, and also includes very amazing customers such as Fox, PepsiCo, CNN, JetBlue, among others. So the problem we're trying to solve is called data downtime. So how does Monte Carlo work? So in Monte Carlo, when our customers start using us, first they connect their data sources that, for instance, could be Snowflake, Databricks, BigQuery, Redshift. And then they also connect the reporting tools, could be Tableau, Looker, Power BI, among others. And then we have the full view over their data pipeline. Okay, so for instance, in this case, we have some different users with different problems, and one of them say, hey, I can't see my data downstream. So one of the things that we do in Monte Carlo is provide a field view over the lineage. So based on all this information that customers give us, we actually have the full Lineage view, we can actually tell users, okay, for a particular assets, what are all the downstream users that that asset has. Or for instance, other here at the second user say, hey, I can't predict where all my data is going to break. So one of the things that we do in Monte Carlo is we detect incidents on their data pipeline. So we can actually alert them when something is wrong with their data. And then finally here, this other user is saying, hey, I don't know, like this particular report, I don't know if it's right or wrong, or if it's wrong, I have no idea why. So we actually here in Monte Carlo, based on the lineage and the incidents, can actually tell users whether a particular report has information that looks good, and if it doesn't look good, we allow them to track down upstream on their pipeline to help them identify exactly where the data got broken, and also give them tools to actually solve that problem. Poor data has actually a very big business impact. So here are some interesting statistics that we've gathered from different places, but we know that, and the first one is actually a benchmark based on Monte Carlo users, that roughly from every 1,000 tables that their customer have, like they have 70 very critical data incidents every year. Okay, then we also know that between 30 to 50% of the time of the data engineer teams is actually spent troubleshooting data incidents. Could be even identifying them, or also like once it happened, trying to understand and fix what happened. And then finally, we know that 26% of a company revenue is affected by poor data quality. It could be maybe because like they're taking decisions based on a report that has wrong information, or because they actually took a decision based information that was wrong and they didn't know it was wrong. But like a big chunk of a company revenue is based, like it could be affected by poor data quality. So that's also why this particular problem is very, very relevant these days. So as I mentioned before, so here in Monte Carlo, we are like the creators of the data observability category. And for us, there are three big pieces to it. The first one has to do with detect. So to detect the incidents that our customers are having in their data. And in Monte Carlo, we provide two different ways of detecting incidents. The first one, it has to do with machine learning detection. So once the customers give us their information, we actually automatically, based on algorithms that we have, we detect the incidents, and the customers don't have to do anything. They just start getting incidents based on these particular algorithms that we have. The second way in which we detect incidents is based with rules that customers can actually write themselves. So it could be maybe rules that are very, they have a lot of business logics, or that are harder for the algorithm to detect, and maybe they just want to have finer control over exactly what they are checking. So they can actually go and write and specify their own rules. Like for instance, they can say, hey, if this SQL rule is returning more than 5 rows, I want to get alerted. Or for instance, if this particular field health, if field in this table is getting more than 5% nulls, then I also want to get alerted. So you can actually have this control over exactly why you want to get alerted, and we are going to run all these rules for you. Then based on all these things that we detect, we also notify you through different mechanisms that you can also configure. Like for instance, you can say, hey, all the very high severity incidents, I want to get to this particular dedicated Slack channel, or I want to get all the low priority or whatever through email. Or so we also give you very fine-grained control over exactly how and when to get notified for your incidents. So that's the first part, that's detect. Then the second part, that's resolve, and this is the one that's actually related to our talk today. And the resolve bit is once the incident already happened, customers now need to understand why it happened, and we give you tools to understand why it happened, so that it's easier for you to then go and solve the problem. One of those tools that we're giving you is FieldLevel Lineage. But then there are other things that we also provide, like for instance, impacts radius. So give you an idea on how bad the particular incident looks based on the amount of assets that got affected and the amount of users that got affected. Then we also give you some root cause analysis. So for instance, it could be that when this incident happened, we noticed that in these other assets, in this other table, we start getting a field with a certain value that doesn't look right. So we tell you, hey, you know what, this is happening. I mean, could this be related? So that is going to really help users resolve the issue that it's already happening. And then finally, the third piece is the prevention. And we're also giving our users tools to prevent incidents from happening in the first place. So for instance, we're giving them a bunch of insights over how the data looks, that they can actually go there and analyze themselves. We also notify when there's a change in schema. And then we also have a feature that's called circuit breaker. The idea with the circuit breaker is that, for instance, you can configure and say, hey, if this SQL rule is breaching, I want to execute this particular process so that I don't want my data to propagate to the rest of my pipeline, so that I actually preventing that incident for further propagating downstream. So those are the three big pieces. Today, we're going to focus on the resolve and the automated field-level lineage feature that we built. And then I also wanted to mention that data observability has what we call the 5 pillars. So there are the 5 areas where it's important to pay attention, and they're also covered in the product. So the first one is freshness. So it's how often is a table getting information, the volume, how much information is getting into the table, distribution, so how does the information look in the table, and then schema, which is the schema of the table, and finally lineage. That's where we're going to focus today. And then, well, why field lineage? So why is lineage important, and in particular field lineage? So there are different scenarios where lineage can be helpful, and they can be grouped into different groups. So the first one, I'd say, is impact assessment. Okay, so that's when the downstream dependencies are important, and the second one is the root cause analysis, and that's when the upstream dependencies are helpful. So let's stop a bit on the impact assessment one. So let's say that, for instance, I have in a table, I have a field that I know has wrong information. Okay, so I for sure know that what the number that's there is not right. So what I want to know now is I want to be certain that that particular bug or error that I have in that data is not used everywhere, or I want to alert on my stakeholder saying, hey, I noticed that this is not right. So I want you to know that all these reports that you're using, all these tables that you're using are wrong. So be careful. So we need to fix this. So that's why, like, one of the reasons why field lineage is important is because in that particular case, having information at field level rather than table level allows me to really deep dive and really filter all the downstream cases that are relevant. Whereas if it was just the whole table, I would probably have much more tables and stakeholders to notify. But since we're doing this at field level, I have more fine-grained control over exactly what was happening. Another use case could be, for instance, I want to deprecate a field, and then I can then get all the downstream dependencies, and maybe I notice, hey, no one's using that field. Hey, no worry, I just deleted and that's it. Or maybe I notice that there's a report, but also no one's using the report, so I can just safely delete that field and that's it. So the second group of scenarios is what we call the root cause analysis, and is when we want to understand why the field has that information. So going back to the original example where I know like there's something wrong with my field, I now want to fix it. Okay, so I want to understand, okay, why did this information get to this field that I know is wrong, and I want to make sure that I get the right information. So then I can navigate upstream and I can see all the places and all the fields that are used for populating the information there, and then I can actually fix the bug. So that's why field lineage is very helpful, and also adds a lot of value on top of having table level lineage. So having field lineage on Monte Carlo allowed us not just to show this information, which in itself has a lot of value to customers, but also to build critical features on top of it. So one of them, for instance, is the ability that it gives us to calculate the severity of a particular incident. So once an incident happened, let's say that, for instance, what I have, like the percentage of null of a column is not the right one. Okay, so if no one uses that field, maybe that incident is not really relevant. No one is going to care that the information that I have in that field is not the right one. But let's say that is a field that I've used for, like, as in this example, like, I don't know, 784 reports actually rely on this field. Then I know it's a very critical incident and I need to take care of it, and also notify all those stakeholders that, hey, this information is not right. Please take a look at these reports. Make sure that, yeah, we fix data before relying on them. So this is one of the features that we build on top. Then the second one is actually, know which are the affected reports, which again is very different, like having the information at field level rather than table level, because we know that at a final level of detail exactly what are the reports affected by a particular field. And the third feature is the personal information tracking. Let's say that I have, I don't know, an email field, and I want to know all the reports that actually use that email field, because maybe I want to put a mask on top of them because I don't want to expose that information. Well, being able to do that tracking and know exactly, like, this particular field, where is it used on downstream on my app, is something that we can do because we have FieldLevel Lineage implemented. Cool. So with that being said, now Xuanzi is going to talk about how we actually build this.
Thank you, Helena. Hi, everyone. My name is Xuanzi. I'm a backend engineer at Monte Carlo. Now we'd like to talk about how we built FieldLevel Lineage at Monte Carlo and the process of it. As everyone in the data field probably know, like, in the modern data warehouse system, most of the things happen through some kind of queries. No matter, like, you're creating a table, inserting data to a table, modifying the table, or whatever, it has to go through some kind of queries. That's why at Monte Carlo, we are building our lineage, both table level and field level, based on the query logs. Go to the next page. Thank you. As you probably can imagine, it's going to be a pretty complex problem. Like, SQLs can be really complex. There are those basic units in a SQL, for example, the where clause, the select clause, the from clause, and stuff like that. And all of them can be actually in subqueries appearing in a field in a select clause or in the where clause. And complex joins can happen in subqueries, and they can just go into subqueries, like into several levels, nested queries and stuff like that can be really complex. And also, in terms of field lineage, there could be two types of lineage that we're talking about. First is the direct lineage. The direct lineage means that the columns on the source table contribute to the values of the columns in the destination table directly. Like, usually columns appeared in the select clause would be like direct contributing to the values. Those are direct lineage. And also, there are lots of fields that are used in the where clause, used as filters to make sure the correct data set goes to the destination table. Those are, like, indirectly influencing what data will go to the destination table. So we call them indirect lineage. Can we go to the next page? Thank you. Like, you probably know, like, if we want to support everything, it's going to take lots of time, and as a startup, it's going to be very expensive. So before we actually build the field lineage, our PM reach out to our customers and learn what they really need, so that we can build something efficient for them at the beginning. The first thing is that they want something automated. They don't want to, us provide API and then they call our API to insert the data. They want to just see the lineage happening directly and then providing them values as fast as possible. Another thing is that anything is better than nothing. Our customers are actually very tolerant of us. Like, they kind of see us grow. We provide new features to them, and then they give us feedback, and then we build along the way to make the product better and stuff like that. The third thing is that if we're going to provide the lineage, which kind of SQL systems do we actually want to support? Among our customers, the most popular warehouses are like Snowflake, BigQuery, Redshift, and on top of that, people use dbt a lot. And on the BI side, lots of people using Looker, Tableau, and stuff like that. So we want to be able to support at least the warehouse part first, which will be coming from the SQL part. The last thing is that we were thinking about maybe just providing lineage for the select, like the direct lineage first. But our customers, they probably don't care about the complexity. They're like, we want lineage from the select part, and also like the indirect lineage that's from the word clause part. So we kind of have to provide like lineage. Given a whole query, we should provide lineage for the whole thing there. So our initial scope was taking 2 months. That's like sometime like late 2021. As you can see, here was our first UI. The table and the selected column appeared in the middle, and we show one layer up on the left side is like the upstream tables and columns that have direct influence or indirect influence to the column like node ID in the middle. And all the downstream tables have like indirect influence from this node ID column. Back then, at our backend, we were carrying like 80% of the queries that we saw, and we are providing lineage from both the selected and also like word clause for our users. And in our next slides, I'll show you what it looks like right now. It's still like one layer up and one layer down, but it's like a much clearer UI. As you can see, all the columns appear there, and then you can select the column that you're interested in, and we're showing you clearly like what's the class selected column and what are the non-selected columns that influencing this column in the middle and stuff like that. And we also have this field level lineage used in incident resolution. Helena will give us a demo at the end about that. And also on the back end, we're covering like over 95% of the queries that we see. But since we have new customers coming in all the time, there are always like new cases coming up that we need to cover. Here it's like the general architecture of our system, like how the lineage actually happens. On the most left side, we have data collectors sitting at our client side, which periodically collects the query logs, basically the SQLs that happened at our client's data warehouses. Those data go through like a kinesis stream to Monte Carlo side. We have something called a normalizer, like query log normalizer, which reads all these raw queries. What the normalizer do first is to call the query parser. The query parser basically takes a string as input like a SQL and then generate the parsed lineage to the normalizer. The normalizer then calls our database to get the table metadata to resolve like the tables we see and tables and columns we see in the SQL. Once the lineage is resolved, we stream it to like another kinesis stream, which get further processed in another Lambda function called FieldLevel lineage data loader, which eventually loads the FieldLevel lineage to Elasticsearch. And our server then expose API that actually guides the lineage data from Elasticsearch and serve it to our clients either on the UI or through API to them directly. During the whole development, the most challenging part was building the SQL parser. As we kind of mentioned, the SQL parser basically takes a string as input and then generates the structured lineage. For example, you can see the lineage, the query on the left side is like selecting 2 columns from a table named the table, and we use like a third column in the where condition. As you can see below it is like the structured lineage. We have the column lineage part, which have all the fields appeared in the select part, and then in the non-select lineage part, we have the fields that from the source table that contributes to shaping the data in the final destination. Can we go to the next page? Thank you. And our SQL parser is built on top of a tool called ANTLR. ANTLR is actually a very popular parser generator. It's widely used in building like new languages, different frameworks and different tools and stuff like that. With ANTLR, you can actually define your own grammar. Based on your grammar and whichever programming language you want to use, ANTLR will generate you the lexer and the parser. The lexer will basically take an input string and tokenize them, and the parser will take the tokenized tokens and then generate like a structured tree, so that from the tree you can extract information from like, you can extract the information that you need to extract. Our parser was built on top of a open source parser, and we added lots of support for different syntaxes for Snowflake, BigQuery, Redshift, and Asana, and some other like query engines as well. Can we go to the next page? Thank you. And after generating the tree, we need to extract the information from the ANTLR actually do that. ANTLR provides us two ways to do that. The first pattern is called like listener's pattern. The second one is the visitor's pattern. Both of these patterns are using DFS to traverse through the tree. But the listener's pattern is more kind of flat. It provides you interface, like when you enter a type of node and then exit a type of node. It doesn't provide you much control over the depths. Like for example, when you go to the let's say if I come to like the top query level, right? I can't really go to the subquery. I can't pass context to it, which will be hard to parse some queries. For example, the one on the right side, as we can see here, we have like 9 CTEs defined, and the final query is basically drawing like a union CTE with like a real table. We have to, like some of the CTEs use the results from CTEs above them. So with a listener's pattern, we can't really carry like the parsed queries above and use those to resolve queries down here. Actually, at the beginning, we had a listener's pattern-based parser, which helped with 80% of the queries, but then for queries like this, it was not working. So we switched to the visitor pattern to traverse through the tree. With the visitor's pattern, it actually lets you enter a node, and from here, you have control over like how to iterate through the children of the node. And then you can actually pass context, like for example, here, we can pass all the already parsed CTEs to whatever query we are passing right now so that we can resolve data here. And also like for subqueries appeared in a from clause, we can actually take the children's result back to the parents so that we can resolve the current layer using the resolve the children query and stuff like that. And it's been working pretty well. And yeah, this is basically how we build our parser. And it's not just me, Helena, and May, who's our PM, built this. It's basically everyone at Monte Carlo built a really strong foundation, all the architectures there for us so that we can actually achieve this in 2 months. And it's an ongoing process. Lots of people get involved in this. Now I'll give this back to Helena. She'll give us a demo.
Great, thank you, Xuanzi. So now I'm going to show how this actually looks in Monte Carlo UI. So this is Monte Carlo UI. As you can see here up top, there are 5 different sections in the settings. So here is where you can actually configure your own monitors. Here we actually show some information around how many incidents were found and the health of the tables. Here we actually list all the incidents that we found. This actually performance is a new section where we actually show information regarding the queries and for each table, what was the performance, and you can actually also configure, we will be able to configure incidents on here as well. And then finally here, I have the assets page. That is where I'm going to show today the demo. And on the assets page, here on this section, we actually show all the information that we have related to the assets that we have in Monte Carlo. So after you configure all your data sources, you will be able to actually come here and search for your tables, and we will tell you all that we know about that table. So I'm going to here open the client hub table. And as you can see here, well, we have some general information. We know here we have like sections that actually correlate to the pillars of data observability that I mentioned before. So the freshness, how often do we get information into this particular table, the volume, how much information we're getting to the table, and then there's the lineage. And as you can see here, we have both table lineage that I can actually see here downstream or upstream for this particular table. And then we also have a section specifically for field level lineage, okay? So what I'm seeing here is like for the client hub table, that it's the table that I selected, I have all the fields on the table and I have the created on field selected. Here on the right-hand side, I'll see all the downstream dependencies for the created on field. And on the left-hand side, I'll see all the upstream dependencies for the field. So if I change the selection here to a different field, as you can see here, it updates, and it starts showing me the upstream and downstream dependencies for those particular fields. So let's go into a bit of detail on exactly how in this case, the created on field lineage is calculated, and what we are showing, what does it mean, what we show here in the UI. So the created on field in Client Hub, here what we have is that it has a select dependency with the created on field on the accounts table under prod stage. And then it has a non-select dependency here with the account ID, account name, and created on field. So as Xuanzi mentioned earlier, we have like both this direct and indirect type of lineages that both are very relevant and important for our customers. So that's why we list them both, and we also make the distinction with these tags. So if I want to have a bit more context onto exactly how these fields are being used for populating the created on field, one thing I can do is to go to the query log section on my table. And here I have it. Okay, and here I'll have a list of all the queries that were executed over my table. In particular, this one is the writes query and the reads query. So I'm going to focus now on the writes because I want to know how this table was created. And if I click here, I can actually see the SQL. And here I can understand why these field level dependencies were generated. So if I focus on the created on field, which is what we are looking at right now, and I come here to the select, as you can see here, the select, this final select is selecting the created on based on the accounts created on field. So the accounts is actually an alias that we are defining here. That is the analytics prod stage accounts table. That, as you can see here, is the table that we are listing here. Then also, and that's why we are listing it as a select, because the created on here is directly selecting the information from that other field. But as you can see here, we're also listing dependencies with these other three fields as a non-select. And why is that? The reason is that for computing this particular field, even though this is the only one that we have on the select, we are also doing a join here with the account ID field. So that's why account ID is also here listed, but with non-select, because this field is used, but it's not in the select statement. We are also doing here a where with the account name. And finally, we're also doing a group by with the fields 1, 2, and 3. So created on, account ID, and name. So that's why these three fields appear here. So that's like a view that you can, something that you can do if you want to have more context. But let's say that now what I want to do really is to just understand where the information is coming from. I want to understand, okay, so the created on, I now know that it's coming from pro stage account created on, but what if I want to keep, to dig a bit deeper and know, okay, but where is this created on coming from? So one thing I could do is I actually can navigate from here into another page. I can actually click that particular field in Monte Carlo, and then this is going to take me to the field level lineage view for this other particular field. So here now I can see that the created on field on price stage account actually relies on another table, on the accounts table, and is using all these fields for getting public. And then I can keep on navigating and seeing and understanding exactly where the information on the created on field comes from. Now, let's look at another example that I find interesting, and it's the number of users. So if I click now the number of users field, as you can see here, the view for upstream dependencies changed. And now instead of having one table, the pro stage accounts, I also have the pro stage users accounts. So I have two tables. Now, why is that? So if we go to the original SQL, we see that for the number of users field, in this case, we are using the table users. Okay, so and the table users is here an alias for the pro stage users. So in a similar fashion that what happened with the created on, we are listing here the email as a select because we are doing here account users email. But then we are also listing these other three fields because these fields are part of the join and the where and the group by clauses. So that's also why these fields are relevant. And the reason why I like this example is because we can here clearly see that depending on the field that we select, are the tables that are going to get listed here. And this is going to really help me narrow down the assets that I need to focus on when I want to analyze a particular field. In this case, in the case of the created on, I only care about the accounts table. But if I really want to understand what happens with the number of users, I need to also go to the users tables in prod stage. Cool. Then finally, I want to show another example. And now I want to show also how in the Monte Carlo UI, we're displaying on top of the FieldLevel lineage the incidents. So let's say that I had, in this case, an incident over the table events. Okay, and I want to understand, okay, but why this event happened? So the first thing that I can do is actually come here and view the incident in Monte Carlo. This is going to take me to what we call incident IQ view. So in this view, we have everything related to this particular incident. So we can actually see the impact this incident is happening, where it was notified, if there's anyone assigned to it, what's the severity. Then I'll have all the charts regarding that particular incident. In this case, is the dimension tracking. So we see the chart related to the values. And so all the information that really helps me understand what's happening. And in this particular case, I know that these table events, the event type field, if I see the field level lineage, I see that actually has like these 4 tables upstream, but just one of them is actually involved in the incident. So I can actually narrow down and focus on the table that actually has the incident, that I can keep going upstream until I found, hey, this table actually doesn't have the incident. Let's see how we're retrieving information into this one. Maybe there's a DBT shop that even didn't run, or maybe something happened here while sending information. But I can really narrow down and see exactly where the issue could be happening, so that I don't actually have to explore all my assets to fix the incident. Cool, so that's it regarding the demo. One last thing I want to show, well, we'll leave some space for question and answers now if anyone has a question, but I also wanted to wrap up by mentioning that on November 8th, we'll have Impact, which is the Monte Carlo Data Observability Summit. This is actually the 3rd that we do. There'll be in-person events, and there will also be online events that you can join. So I'm inviting you all to sign up for that because it's going to be great. So with that being said, yeah, happy to hear if any of you have some questions for us.
All right. Well, wonderful. Thank you so much, Helena and Xuanzi, for that wonderful presentation. I think it was just so in-depth. We just don't have any questions. I mean, you guys did such a great job. But they did have their contact information there on the screen, so you can follow up if you do have any further questions. And everyone will be getting a copy of the presentation as well, so you can follow up with them there. You can obviously find them on their website. So be sure to check out all those things. And thank you guys so much for joining us. We really, really appreciate y'all spending some time with us, sharing some more information about this really important subject, right? It's important that we keep our data systems healthy. So this is great information. Thank you guys so much. And I also want to thank everyone else who's joined us. We really appreciate you guys spending some time with us today. And be sure to check out our website, dzone.com/events, where you'll be able to find this webinar and a whole bunch of other great events there. So be sure to check it out. There's a lot of really important topics for developers today. So be sure to check out all those things. Thanks again so much. We hope everyone has a wonderful rest of your day, and we'll see you again real soon.
Thanks a lot, Jason, for having us, and thanks for everything that you're doing at DZone. It was a pleasure.